What is up, YouTube? Welcome back to another episode on Code with Annie. In this episode, we are going to continue looking at the collections interface, and the very first collection in our category of items to look at is the list interface. Okay. Now, like shown in the previous video in the overview session, a list is one of the interfaces that implements the collections interface extends the collection interface, and ArrayList is an implementing class which implements the list interface. Okay. Now, there are two types of implementations for the list, okay, broadly. They are, one is, let me put the multi-line comment, one is the array list, as you can see above. The second one is called linked list, okay. Now, I'll tell you the difference between these two, okay. Array list, as the name suggests, right, is actually an array without any size that is initialized by you, okay, without a size specified by user. Okay, so when I say new array list, it will actually create a dynamically sized array in memory, which will keep expanding as and when you add more elements to your array list. Okay, it doesn't have to have any predefined memory that you want to set. There will always be some memory that is allocated, and if that memory is about to be breached, it will automatically expand itself so that more elements can be added to the array list. Alright, and the reason it's called array list, one more reason it's called array list, is because it stores the information in the form of indices, just like an array does, right? Array is accessed through indices, right? You have array of 0, array of 1. So similar way, it will show the information as well in array list. Okay, the storage part will look like an array, but the only difference is, like an array, it also has a defined size, but not something that you have to provide explicitly. It will have some defined size and it will grow automatically. Okay. Consider it like similar to a vector. As I mentioned, vector, right? It can automatically shrink or it can automatically grow, but it will look similar to an array. So same way, array list as well. Only difference is there is a synchronization difference between array list and vector, which I'll talk about in later videos, but that's not important right now for this video. But yes, array list, consider it like a dynamic array. Okay, that's the definition of it. Okay. Now, linked list, on the other hand, is slightly different. What linked list does is, it creates a node object, okay, in memory, which will have the information that you want, that is the data, and it will have the address to the next node. Okay, what I'm trying to say is, this is how internally a linked list will look like. Okay, consider node is a class. Okay, let's say there's a class called node. Okay, in that class node, you will have this information. You'll have let's say int. Suppose this linked list is a linked list of integers. Okay, it will have int data, and it will have int next pointer, and it will also have int previous pointer, which means int not next, so it's node next and node previous. Okay, now what I mean to say is like, this is how the data is linked in the form of a list. Okay, so one node has a reference to another node, and this node also has a reference to the previous node, so it looks like a chain of nodes, right? This is how it will be: node 1, node 2, node 3. And the thing with this is, this can be located in any address. Okay, it need not be contiguous allocation of address. Like in array list, the array is most definitely allocated in some consequent spaces. Okay, so everything will be together, something like this: a1, a2, a3. Okay, so these are all contiguous memory allocations, whereas in linked list, node 1 can be sitting in one address and it will have a reference to the second node, so it can be in a different place. But since with this reference, you will immediately navigate to that. So picture this in mind, it will be like a web. Okay, and in that web, if you see, right, you've seen a spider's web. Similar way, the linked list will be designed in memory, right? One node will have a connection to another node, and that node will have connection to third node, and so on and so forth. Whereas in array list, everything will sit together side by side, like you see people sitting in an auditorium, right? Side by side. So same thing. Now, the difference in real world usage is, array list is generally the preferred data structure they use. The reason is, array list is literally faster for most of the operations. Okay, linked list is faster for operations that require manipulation of existing data. Let's say there is already some data in the linked list. You want to delete that node, or you want to add a node to the beginning, add elements to the beginning of the list, remove element from the beginning of the list, or add element to the end of a list. remove from the end of the list. So if you have such specific requirements or specific manipulations, linked list is faster. But in most general scenarios and most real world code bases that you see out there, will prefer the use of ArrayList over linked list, because ArrayList is simply an array without any specific fixed size in memory, right? It can keep growing, and it has a contiguous allocation of memory, so it's very easy to access through indexes, and it always takes a constant amount of time. So I'll talk about time complexity and space complexity in a different video, and I'll explain how it's computed. But for now, just know that ArrayList is generally faster than linked list, okay, for certain operations. Now when I say linked list, right, so let me create an instance of linked list as well and show you what is there in it. Linked list space linked list is equal to new linked list. Okay, so when I say linked list, a linked list is basically it implements the list operation, and also you can see it implements something called Dequeue, right? And what is Dequeue? Dequeue is an interface which extends the queue data structure. So I mentioned 4 different data structures, right? I mentioned list, set, stack, and queue, right? So queue was one of them. So if you observe indirectly, linked list implements the queue interface as well. The reason for this is because in linked list, you want to add elements, as I mentioned, right, to the beginning of the list or to the end of the list. So when you want to deal with something in the beginning or the end, right, a queue is very much useful, right? Because when you dequeue, what is dequeue? Dequeue is basically the process of taking an element out of a queue. Okay, enqueue is the opposite of it. Putting an element in the queue is enqueue. Removing an element from the list is dequeue. And how do you remove from the queue, right? Queue is something called as first in, first out, right? In the world of queue that you see out there, if you stand in a queue, right, if you are the first one in the queue, you will be treated first, and you will be out of the queue first, right? Same way, in a linked list, if it follows the dequeue operation, it means whatever is put in the list first will be the one that will be dequeued or removed first. As I mentioned, one of the operations in linked list, right, remove first. Yeah, so that can be achieved using the dequeue. That's why it inherently implements the dequeue interface as well, which actually extends the queue interface. Okay, and if you look at ArrayList in the same light, where is that? I think I opened a lot of library classes here. Just a minute. Recent files, main.java. I'll go here. Yeah. If you go to ArrayList, ArrayList is something that, let's see what it implements. It implements the list interface, but it does not implement the queue, if you observe, right? It implements the list, and list extends sequence collection, and it extends the collection framework. All right, so that is the difference between different types of lists itself, right? One of them extends the queue interface, whereas one of them implements just the list interface, right? So that's the difference, and both of them have similar properties. So if I say list dot add, I can add one element, I can add multiple elements. Add all will add a collection. Already existing list I can add to another list, append to it. Add last, add first is also available here. Okay, same way, if I say a linked list, let's see what does it have. Same thing it has, again add, add all, add first, add last. Okay, contains get first, get last is there, correct? So get the first element, get the last element. Let's see if the same thing is present in list dot get first, get last. Yeah, it is also there here as well. Okay, so there's no difference here. All right, but internally this is how they work, both of them, right? I hope this video was quite helpful for you guys. If you liked it, hit the like button and subscribe to CodeWithAni if you haven't already, and I'll see you guys in the next video with some real world examples of manipulation of these lists. Okay, bye bye guys.